Then if we could debunk some notions, and I know that you have done it before in other interviews, but I think that the listeners would immensely benefit from you actually breaking down what is machine learning and what is deep learning and what is artificial intelligence in your opinion, educated opinion.
Right. It's important to understand that it's not worth fighting over how a word is used. So I'm not going to say this is the right way to use these terms, but I will say that it is an educated way, one of many educated ways of using the terms, and it's how I tend to use the terms, although everyone makes mistakes, right? But a very clean understanding of intelligence that separates it from a lot of other pieces, so we can have discussions about that, is that intelligence is just doing the right thing at the right time, right? And we sometimes extend from that to say, in response to environmental change. That way we don't say, oh, the chair is doing the right thing or the rock is doing the right thing, because it never changes what it's doing, right? So why would you want such a simple reductionist kind of description? Because you want to say something like, well, how important is intelligence to being, for example, a moral agent, something that's responsible for its action? Or is intelligence all there is to cognition? Is, and now cognition, the definition I just gave you of intelligence is pretty much what you get from behavioral ecology. It's definitely exactly what you get out of Patrick Winston, who used to be the textbook in AI. But there isn't such an agreed definition. Everybody uses something different for cognition. But when I talk about cognition, I talk about one step up from intelligence in that the definition I gave allowed you to say that a plant is intelligent because it can sense light and it can grow towards the light. You know, trees drop their branches. They just say, okay, there's no light over there anymore, right? They even have memory.
Isn't there something like this with rocks too?
No, because, I guess you could say that they wear away. So some people talk about rocks having memory because you can see where they've been or something like that. But it doesn't sense and then act in response to that. So it's not actually doing something as a consequence. So there's a two-wayness about life. So anyway, that's life, and then also thermostats. So I'm on the Marvin Minsky side of saying that the simplest AI is, for example, a regulator on a mill, which is not even a CPU, right? It's just something that's mechanically helps keep the mill going the right speed. Or a thermostat. You could make a thermostat just out of a coiled spring. That's how we used to do it. You know, a coiled spring and a magnet, and then that would turn on or off depending on how cold or hot the room was, right? And that's like really, really basic intelligence. Now, so I would call those intelligent, but I wouldn't call them cognitive because they can't learn how to learn. So they can't learn ways to create new representations. And that's one of the things that we get really excited about with humans, that they develop and their representations change over time and they're able to do more things when they're older than when they're younger. And then you have these big questions like we had today about like, well, can bees do the same thing? And are bees cognitive? And there's some pretty good arguments that bees are cognitive. So anyway, so you asked me about machine learning. Some people, I hate this, but some people who are trying to sell what they do say, oh, well, in the old days, AI was something we programmed, but now AI programs itself. No, nothing programs itself. There's no algorithm that you imagine and then suddenly you spontaneously get a program, right? Or a robot or something. What you have to do is, one way to think of it is that machine learning is one of the tools that we use to build AI. And first we have to choose the algorithm. We have to supply a lot of power, a bunch of time, and a bunch of data. And then we choose which data we put into it. Sometimes people talk about supervised versus unsupervised learning. But even there, I think that's a bit, it's always about how much supervision do you give. So do you actually say, like, here's a label for every single piece of data, here's a label, or do you just sort of reinforce the whole system for finding regularities, for being able to detect that something is, Though at some level, you don't have a learning system if you don't have a means to tell that you're wrong and a means to update yourself based on the information that you're wrong, right? So there's always, every learning system has those components. It has a representation that you're storing the information as you get it, and then you have a way, and then you use that if you have an actually intelligent system. So by this definition, you could have machine learning without intelligence if the system doesn't do anything with it, if you're just sort of recording it. But generally speaking, if you're talking about anything that has agency, then you have this representation that not only do you store experience in, but also that you use to predict what the right action is. And then if that action turns out not to be right, then you need to update the representation somehow. And so those are the pieces every machine learning system needs. And so we build them, and we're the ones who provide those pieces, right? And so that's why I'm saying even that, even for a machine learned system, there's still human responsibility for it, even though we don't micromanage all the details. Then finally, deep learning is just one special form. Although there's a great story behind deep learning. So deep learning, one of the most essential things about it is that you have multiple layers to the neural network. And the problem was, when I was a grad student in the 90s, someone had already proved that mathematically proved, formally proved, that you never really need to have more than one middle layer, right? Everything you could do with however many layers you have, you could do with a single middle layer, in theory. And so when I was a PhD student, you couldn't do anything that had been formally proved to be silly, right? And so but people like me, I came from psychology. I didn't come from computer science or math, so I didn't care about proofs that much. I mean, obviously you take on board if someone tells you it's impossible to do something, then you think, well, probably it is. But what those guys neglected was that, okay, yeah, you could in theory do it, but you're much more likely to get successful learning if you actually had these not only different layers in between, multiple layers, but depending on the size of those layers, they turned out to be more likely, the bottlenecks in the learning were more likely to discover certain kinds of information. So it really matters. And that's, here's another great funny thing about this is that DeepMind was, of course, famously bought from Google for this huge amount of money. And they said, we're going to solve, artificial general intelligence. We're going to solve, that's what we're doing. We're able to learn, any Atari game or whatever. But the whole reason that you would spend whatever that was, legend has it 400 million pounds. I don't know how accurate that number is. Anyway, they got a lot of money, and it was because those guys are so good. And the reason you need people who are really good is because there is no systemic way, or you just program it, right? So it was the irony of having a bunch of people being paid so much money because they were individually such superstars, and then to say that, oh, we're doing general intelligence, it's just really funny.